I like that problem already. Let's see. Frequency of a violin string varies inversely with the square root of the density of the string. So the very first thing to realize, inversely. With an extra E in there. So the frequency of a violin string varies inversely with the square root of the density of the string. So if I call frequency F, does that make sense? We'll call density D. And real quick, this is the part that, this is one reason why I assigned this, so that I get this question so I can talk about it. If I didn't get this question, that'd be too bad. So if the frequency varies inversely, so it doesn't vary directly. So if I vary directly, as I get older, I get taller to a certain point, right? So that would be a direct relationship. As one gets bigger, so does the other one. Inversely would be the reciprocal of it. So frequency varies inversely with the square root of density. Right? Blah, 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 blah. And then they say, oh, is this? Yeah, this is after synthesis. Good. Blah, blah, blah. They give you so what we don't know is what goes on top. We don't know what that multiplier is, what that constant. There's a constant up top. You guys kind of with me? Yeah. So the more hours I work, the more money I get, right? If I have a salary job, a wage job. The more hours I work, the more money I get. You with me? So if I work 8 hours, then I'll get 8 times something. I just don't know what that multiplier is. Does that make sense? Of course, the multiplier would be how much money you make per hour. How are we doing so far? So your wages varies directly with the time you work. Thank God it doesn't vary inversely. Right? Work more time, get less money. Screw that. Well, that would be nice. Just stay home. I just don't know what that constant is that goes up here. So we'll call it, what do you want to call it? Okay, cool. So we'll call it X. Not the best choice, because it's a constant, but I'll go with it. And then they give me like 2 situations. One situation they give me is, if it has a density of 1200, it vibrates at a frequency of 250. Right? So if the density is 1200, the frequency it vibrates at is 250. How are we doing so far? Yes?
In this chapter 13.
This is 12.6. Number 68. 12.6, yeah. Okay, so far, so this is what they mean by varies inversely. The frequency is some constant divided by, that's the inverse part, divided by the square root of the density. So it varies inversely. Then they tell me D and F. So, of course, that means I can solve for X. I'll know what the constant is. So that's the number that doesn't stay, that doesn't change. Yeah, let me call that C, because it's kind of bugging me, this is X. So it's a constant. So if I plug in there 250, C over the square root of density is 1200, you guys can solve for C, right? Could you solve for C?
Yeah, multiply.
Yeah, just multiply by whatever square root of 1200 is. Okay. Once you have C, you can do the rest of the question. The rest of the question says, what is the frequency if it has a density of 1300? Well, if you solve for C, then you'll know what this equation really is. It'll be F equals some number over root D. And then you just throw the density in here and solve for the frequency. All right, so who's got C for me? Anybody doing that for me? What's 250 times the square root of 1200? 10 squared, 12, 20 squared, 3, 30 something.
Numbers.
34.641.
Okay, so I get C equals 250 times 34 point whatever. So 250 times the square root of 1200. Let's do that. And then you figure out what that number is there. Do it again. 8660, roughly?
0.254.
Okay. So that's what C is, and now if they tell you what the density is, you can just divide that by that. So for this material. C is a constant, and I can make it a different density. But C doesn't change. C stays the same. So now if they tell me a different density, I can figure out what frequency it vibrates at. And that would make a different note, right, if you have any musical background. Just to remind you guys, if you're sitting here freaking out because you haven't looked at this yet, this is a synthesis problem, which means it is a bonus problem, which is cool. Because if that's the only one you had trouble with, you're okay. Okay? Yeah?
12.8, 108.
Oh, yeah, okay. So that's all you guys got from me today, the synthesis. All right. So has everyone got what they want from there? Okay. So part of what we don't talk about, but I wanted to assign this problem anyway, is once we learn about complex numbers, you might wonder, well, how does that fit into what real numbers do? So we looked at multiplying, we looked at dividing, we looked at all the operations, but then what about graphing? What's one way I can graph complex numbers? Right? So to graph a real number, just to graph a real number, how would I graph a real number? Not a point, just a real number. How would I graph it?
X and Y.
No, not even x and y. It's just a real number. It's one thing. So if I want to graph the point 1, I'm done. Yay. So one very simple way to think about graphing complex numbers is, why don't I add in another axis, but this is the real axis. This is a real number line. If I add in another axis, that'll be the imaginary axis. Right. So now if I have a number like... -1 plus 2i. So then I can look at it like a point almost. I can look at it like -1 is the real part, 2 is the imaginary part. And that's all there is to it, right? So like x plus yi. So how would I plot this complex number?
So
Back one.
-1.
up 2.
Up 2, there's that complex number. Yeah. So this is not, we go from real numbers to real points. And then we add in x and we add in another real axis, right? So I can plot 2 real numbers as a point. This is plotting a single number, but it's got a real and imaginary part. So this is the most basic way you might think to do that. Yeah?
For D, it says 4. Would you just place a point on the x?
Yeah, that's awesome. So if I want to plot the point 4, that's plus what I?
0.
Exactly. So that's the point 4, 0. So 4 is completely real. It should only show up on the real axis. It shouldn't have any part off of there. That would be imaginary. Right? So all real numbers would just live here. The minute I add a little bit of imaginary, it's going to go up or down from there. Good. Jesse, and then...
So this is an x-axis and a y-axis. This is a real and
Beautiful.
a complex.
So this is a real and an imaginary.
All right.
Yeah. Again, a complex would mean a mixture of real and imaginary.
Right.
Good. Yeah.
So do you kind of not look at the I and just look at the numbers in it?
Yeah, exactly. You look at the coefficients.
So if it was just I, is that 0, 0?
No. So 4 would be just 4 plus 0i. If I have I, what is that plus? What's the real number part? If you just have I, if it was 1, it would be 1 plus I. Since there's nothing, it must be 0. So then it would be the point basically 0, 1. So if it's purely imaginary, it's going to be only on this axis, because that's the imaginary axis. If it's purely real, it's going to be exactly where we always put real numbers, so on a real number line. If it's a mixture, it's going to be somewhere off axis. Does that make sense?
I thought the I was like half of 1. Yeah. It was like I squared that was...
I squared is -1. What is the coefficient of the I?
1.
1.
There you go. That's where the 1 came from.
next to the I.
Here, it would be 2. Right? That's like B, A plus BI. Yeah, so I'm not plotting the value of I. I know what I is. I'm plotting, how far away it is from being real, right? It's like 2 steps up from being real. Does that kind of make sense? That is one way to look at that. The further up I am, the further away it is from being real, in a sense. Right? Taking that many steps, that many complex steps.
I equals square root of -1.
Beautiful, that's right. I equals that. And that's one reason why we call it i's. We don't know what the hell it is. Yeah. Again, this is a bonus point. This is a synthesis problem. I just want you to know that this method of graphing complex number exists. And it's pretty straightforward if you just look at the coefficients. There's a whole other method of graphing complex numbers using colors, which is kind of nice. But we're not going to do complex analysis here. Let's not do that. Yeah.
Wait, so that's not gonna be on the test?
No. If I put any synthesis problems on a test, it will be in the bonus section. I assign synthesis problems just to push you a little bit. But if they're the only ones you're having trouble with, you're doing great. Does that make sense? Because they're bonus problems, yeah.
Those aren't on my math lab, right? Or
I can't remember. My math lab only allows me to assign so much. It doesn't open the whole thing up to me.
oh, okay.
So if you do my math lab, you're just not being challenged. I'm sorry.
You're not.
I'm being shown.
Yeah.
And please, number 45.
I thought somebody might disagree. What?
Number 45.
Where?
12.7.
Okay. Oh yeah, this is awesome. Okay, sorry. I didn't mean to be so excited. The weird part about this problem is the units that you have to be careful about. You're talking about the bridge, right? Okay. Yeah. During the summer heat, a 2-mile bridge, so it's 2 miles across.
I think it was 2 miles plus or 5 feet.
Yeah, this is what it is normally. And then the summer comes and it's going to expand 2 feet in length. So think about it. If the only thing it could really do, there's a couple ways for it to do this, but one thing it could do is just buckle in the middle and kind of push up. Because if it expands, it's better that stops soon. If it expands, it's got nowhere to go, so it's got to kind of push on itself and bulge up, sort of like plate tectonics, if you like geology better, or not if you don't. If we assume that the bulge occurs straight up in the middle, and that's a big assumption, but what the hell? How high is that bulge? So the summer comes along, and then it goes something like that, just to overstate it a bit, right? It's definitely not to scale. So they say, how high is this? It's still 2 miles long. So it expands 2 feet in length. So the length of it is 2 feet longer than it used to be. Right? So now it's the total of this is now what?
52.1.
Yeah, 2 miles and 2 feet. But they could have expanded by 2 feet. So now what they're really asking is, how tall is this? So what's the base of this little triangle I've made now?
2 miles.
It's still got to be 2 miles. Exactly. You with me? So normally it's 2 miles straight across. It expands, and that expansion has to go somewhere. It can't push against the whatever's over here, the concrete or the land. So it just kind of pushes on itself and goes up. So this distance here is still 2 miles. It's just the actual bridge is longer than 2 miles now, so it can't fit straight across. It's got to push up a little bit to fit now. What's a little weird about this is the units. You might want to convert to pure feet, right? So you have all the units in the same, all the same units. You with me?
Does it ask you how high in feet it is, right?
I don't think it says.
Mm-hmm. It did on my math lab, that's why.
Oh, okay. It doesn't here. They're not as nice in the book on that one. Blah, blah, blah. So that is a good hint to give. Anybody remember how many feet in a mile? 5,280. That's a good conversion to know. 1 mile is 5,280 feet. Yeah, that's so much better than metric. No. So 2 miles would be...
But you don't need to know that, do you? Because you're going to cut
10
it
by
in half.
60.
I mean, you don't need to do that. You're going to cut it in half because you're figuring out for a right triangle.
Yeah.
So
This is
just
true.
write 5,280 plus 5,280.
True. That'll be fine. So because you got your right triangle here. So this will be 5,280. This is 5,280. So what's one of these?
5281.
So this will be 1 mile, 1 foot. So it's 5,281. Right, so that's the part I want you to be careful about is you can't have the 2 feet all on one side. It's got to be distributed. So it doesn't seem like a lot. The 2 feet, it doesn't really seem like a lot. But now how do you calculate this? Now it's pretty simple. The hard part of this problem was setting a triangle up. How do you get this side now? Pythagorean theorem. What's your hypotenuse?
5281.
Yeah, it's the side across from the right angle. You guys kind of with me? So what you're doing in this section especially, but in general, you're always looking for these right triangles when you talk about side lengths. Because I know exactly how the side lengths in a right triangle interact. I know a lot about them. So if I can find a right triangle, I can use Pythagorean theorem, right? If I can't find a right triangle, that sucks. I got to use some more advanced trig stuff. So what would the equation look like then?
5280 squared plus b squared.
All right, good. So you can call that one A, and you can say this one is B. I don't know what that is. Equals 5281 squared. I'll keep going because I want to see the answers. It should end up being around 100, 110 feet or something.
102.
What is it?
It's 102 something.
Yeah.
Yeah.
So if you, at the end of this, if you subtract this, square this out, subtract that, and then you take the square root of whatever you get after all that stuff, you get about 102 feet.
102.766.
Isn't that crazy? So the bridge itself just becomes 2 feet longer, and it's got nowhere to put that extra length, so it's got to push up in the middle. This isn't 2 feet. In order to fit that extra 2 feet across, in order to fit that extra 2 feet here, this has got to be 102 feet up. So, thank God, they figured out how to put some allowance in there to allow for expansion and contraction, right? You ever see those, like, teeth that fit in? There's other ways to do it so that if it expands and contracts, it's got somewhere to go, instead of bulging by 100 feet up, right? Driving your car like, that wasn't there yesterday. Pop. All right, so that was a good question. That was a freaky little problem. One that I liked a lot. Okay, so anything else from homework?
There was one at the end of 7-8 in my math lab, but I can't remember what the number was. It was like,
12-8?
yeah. It was one of the, like, I to the blank plus I to the blank. And it was weird. Took me a minute to figure it out.
Oh, okay. With like I to the fourth plus I cubed or something?
Yeah, something weird.
All right, so then you just treat each of those separately and then,
Yeah.
yeah.
Still don't like I. But I don't think we have a choice.
Right, math, self-help books.
We should.
The road to liking I. So. Yeah.
I for dummies.
Yeah.
25 and 12.7.
Number which one?
25.
Oh, yeah, okay. So this is something that we all experience at some point, is trying to figure out how long of a wire I need, cable or anything else. Stereo receiver's in a corner of a 12-foot by 14-foot room. Wire will run under a rug diagonally to a speaker in the far corner. Okay. If 4 feet of slack is required on each end, how long a piece of wire should be purchased? So that last part, so whatever I figure out this is, I'll just have to add on
8.
8, because you need 4 feet of slack on each side. So at the end, I'll add 8, just to cover that 4 feet of slack.
Why?
Because if I get wire that fits exactly from that corner to that corner, I won't be able to do anything with it. I won't be able to lift it up and actually connect it. So they want 4 feet of slack so that they can actually connect it to something. Right, which is useful. Right. So I don't want to just have it exactly lay down on my floor. I need to be able to pick the damn thing up and then connect it somewhere. So I have to add in 8 total feet of slack so that I can connect it to places. Is that cool? And who cares why? The problem just says that they want it. Right, so we're going to give the people what they want so they hire us again. Blah, 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 blah. So how the hell do you do this? So now that you've drawn a picture, or you watch me do it, it becomes a question of how to find this length. And what do I look for always when I'm trying to find lengths? If I can find this, like, it's easier.
Society unknown length of one of them.
Okay, there's a length I don't know. This is good. Length I don't know.
C.
Or C, sure. And what do I look for to help me find it? I got a triangle. I got a right triangle, which kicks ass. I got 2 right triangles, but I got, for example, I got that right triangle there, right?
Yeah.
How do I find this? This is not,
8
this is a little troubling.
Or 14 plus 12.
Yeah, 14 squared
14
plus 12 squared equals C squared. Once you have C, you add 8 onto it, so you get that long of a wire.
C squared plus 8.
Alright, I'll let you guys finish it out.
So the answer is C plus 8.
Yes, at the end, whatever you get for C, you got to add 8 feet on, so it's got that slack to come off the ground. Okay. Anything else from homework? All right, just to maybe spur some quiz tomorrow. Woohoo! 12.6 through 12.8. That. Yeah.
12.7.
Oh. This one sounds weird when you first read through it, right? Everybody take a look at number 50 on page 780. This is the one about the find all points on the x-axis, right?
Yeah.
Okay.
Okay, yeah.
Try to draw that out if you haven't done that one yet. But try to not let me realize that you don't have your book with you. What's up? Yeah, let me write it up here for you.
So it's actually quite interesting, but
Find all points in the x-axis that are 5 units away from the point 0, 4.
0.04.
That's it.
No, it's not. That's it. But
All right, so to graph this, where's the point 0, 4?
Or
Yeah, so it's on the y-axis. This would have been an easy-ass question. They would have said the point was 1, 0, and then 4, if it's 5 away, just go up 5 and down 5. Yay! It's not that easy here. If I go straight down, I hit the x-axis if I go 4 steps. Shit, I have to go 5 steps. So I have to go diagonally. Right? So when you don't know for sure how far it's going to go, you just kind of pick some arbitrary point. And then we'll see how right we are. Right? I want this distance to be 5. So what have I just created?
A triangle.
And whatever answer this is going to be the negative of it, right? Same thing on the other side. You guys kind of with me? So I only have to focus on one of these triangles. Yeah. How long is this side?
4.
Yeah. That's 4 up. I want this to be 5, so how far out do I have to go?
3.
Good. I want this to become a triangle you know. 3, 4, 5 triangle.
In my math, I would ask you a little different.
I like it.
It says, it's 12, 20, and 16. Or 20, 12, yeah, 16.
I like it, but it's still a
It's
nice,
still 3, 4, 5.
it's a multiple of 3, 4, 5.
Yeah.
So, I mean, how do you do that if you don't know the 3, 4, 5 triangle? How do you find this last side? What's your hypotenuse? 5 is my hypotenuse. It's across from the right angle. So when I do this equation, how would it get set up?
16 plus b.
Yeah, 4 squared plus b squared. We'll call this b equals 25. So b squared equals 9. B equals 3. There's your 3, 4, 5 triangle. Right? There's a few triangles that the sides come out to nice whole numbers.
11, 12, 13, or something.
No, I've just forgotten all of them. There's a 7, 24, 25. There's a 5, 12, 13.
That's what it was, yeah.
So forth, so on. Yes, sir.
I did it using the distance formula.
What's that?
I did it using the distance formula, where since you already had one of your points of 0, 4.
So, Chris, real quick, why is that the same thing as using Pythagorean theorem? What's the distance formula based on?
2 points.
What's it based on? What idea?
Finding an unknown distance.
Not what does it answer. How was it created? It was created from the Pythagorean theorem. So if you use the distance formula here, you're doing the same thing we are. It just actually looks a little worse. All right. The reason I can use Pythagorean theorem directly, I don't have to use distance formula, is they're all on axes. They're all like 0, 4, and 3, 0. I mean, they're nice. They're not like 3, -5, where I have to do x2 minus x1 and all kind of stuff. But distance formula will work beautifully here. It's not a problem. It's the same thing. So the key here, obviously, is draw the picture when you're doing anything geometrical. Because then you'll notice things. You'll be able to find your triangles. You notice what's going on. Okay. Anything else from homework? Okay. So what I want to do today is... Well, we'll see. I won't say it out loud. We'll get as far as we can in chapter 13. So part of section 13.1, we already know. So let me do a couple things here. So solving quadratic equations. This is kind of like what we're getting into. And most of us, actually the other day I found out that maybe about half of us know the quadratic formula. And the other half has forgotten it or something else. So if I want to solve a quadratic equation, the one that we've already done, there's a couple of types we've already done. There's this one here. We've done this one of the first things we did. Talk about, let's just get away, but how do you solve that? Factor it, and then go from there. So one thing we're going to talk about today is what the hell do you do if you can't factor it? Right? We're going to do it a long-ass way, just for a little bit, and then we're going to do the shortcut. Right? That's how we normally do things. So here, how's this factor? Good. So you get x equals 11. Cool. All right, that's nice. So when it can factor, kick-ass. An even more kick-ass situation would be something like this. Now, yeah. Normally, I said if this side is not 0, you have to FOIL this back out and so forth. Why do I not have to do this? This is a special case. This is not two separate things. This is one thing squared. And we know what to do to both sides to kill that square. Square root. But the one thing you got to be careful about is what? No?
It doesn't cancel the x minus 1, it just cancels the square root.
What have I done wrong?
Plus that negative.
Yeah, plus and minus, right? Cool. Cool. And then the square cancel on that side.
X minus 1.
So x minus 1 equals
Plus or minus.
plus or minus
3.
right? Root 9 is 3. People are always, not always, thank God, but a few people come up and say, where's my plus or minus key on the calculator? There's two answers here, and you do each one separate. Right? How do you solve for x?
Add 3.
So I get x equals 1 plus or minus 3. How are we doing so far?
I swear I'm
You guys kind of with me? Okay.
So you leave your answer like that?
No?
I can't do it.
Just want to stop and make sure it's moving so far. So you get x equals 1 plus 3, or x equals 1 minus 3. So x equals 4, or x equals negative 2. Cool.
Wait, so you want to do x minus 1 equals negative 3 and x minus 1 equals 3?
Sure, you could do that. You get the same place.
You mean the same
Yeah.
answer?
Of course.
Okay.
Yeah. At some point, that plus or minus has got to be broken out into its two cases, right? And you could do it earlier. That's fine. How do you go so far? So that's not too bad.
Foiled it out.
Yeah, exactly. I could FOIL this out, subtract the 9, refactor it, right? And I'd get the same two answers. So very quickly, since you said that. If I did FOIL this out, what would I get?
X squared minus 2x plus 1
And then the next step I
minus 8.
minus 9, so I get negative 8 here. And how do you factor that?
X minus 4, x plus
Yeah, x minus 4, which would lead to this. X plus 2, which would lead to that. Yeah, so you get the same answer either way you do it. Cool. Yes, sir.
But you don't care which way we do it. I'm just saying because on some of the problems, it says a particular way to do it, so I'll just...
The bad part about this way, now see how the answers came out nice? The answers came out whole, which means if I did it that way, it would be factorable, easily factorable. Are you with me? Since I got nice answers, and math doesn't care which way I solve something as long as it's legal, I got nice answers here, that means this should have been able to be nicely factored. Well, I always get nice answers here. No, I could have made that 7. And the whole thing goes to hell, right?
Yeah.
I get answers like square root of 7 now, right? Which means if I don't do this way, if I go straight to that way, I'll do this and I'll get somewhere I can't factor it. Shit, I got to go back and do this. So if it starts in this form, I would never do that way. Because this form is guaranteed to get to an answer nice. Does that make sense? So I'm glad you asked that question because it really shows you why this is good at all. This is too simple of a problem. So what if I had this? I like it. So are you guys getting rather disgusting answers?
No.
Yes, it should be. Right. Unless it depends on your definition of disgusting here, but disgusting normally means not whole. So, in fact, here's irrational. The very first thing I do, square root,
No, I forgot to do that.
plus or minus. That means I got, it's going to be irrational. So I get 2x plus 5 equals this.
Minus 5.
Good. Solve for x, I subtract 5.
5 by 2.
And I'll show you what I always do. I just always put whatever that is in front.
Plus or minus square
Doesn't
root
matter,
over
but-
2.
And then you go over 2. Or,
That's way too much.
But either way works.
Yeah.
excuse me?
I mean, either.
Like,
This is way too much work.
No. I was talking about the negative 5 over 2 plus or minus.
Yeah.
Oh, yeah, I got you.
11 over 2.
I'll take either way then, if you want to split it up or not.
My math lab won't. It makes you split them up.
Okay. That's another reason why I make it optional. So if that's
So
the
you know,
problem,
if
you
you're
chose
using
it
my
too.
math lab, you have to switch. You have to write it.
Yeah, math lab has very limited tolerance in some formats.
Because sometimes it's one way and the next time it's another way, and you're like, what the hell?
All right. Again, that's why I made it optional, so I can just kind of point out you chose it. So there you go. The day that I make it mandatory, then I have to actually deal with all that shit.
But we don't have to deal with sentences, so it's okay.
Exactly, so it's a trade-off. What does this mean? If I were to FOIL this out and subtract the 11 over, kind of like we did over there that second way, what would I get to?
Put on factor.
I get to a point where I have something that's not factorable.
Right.
And we couldn't solve it then, right?
Oh, well, on the test, like, you want us to get them into that. You can't just wait for them.
If this is the answer, I want you to get exactly this, yes.
Well,
Or
it's
that.
like, when you said subtract the 11 over, and then and it's prime, never mind.
Yeah, if it's prime, that's the wrong way to solve it.
Oh,
So it's not good enough to stop and say it's prime. You shouldn't have done that way. You should have done this way.
Oh, okay.
Because it's not no solution. It's just, I can't factor it, so I don't know how to get the solution.
Oh.
But you should have just stuck with this way. Cool. Okay, maybe. All right.
One, I was looking at it, there's a lot of graphing. Are we getting to that then?
Yeah. Don't worry. Oh yeah, graphing is just talk about how many answers you could get. So it kind of makes sense if I have a situation where, what do I do if they give me a problem that's not factorable? So it's not my fault. I didn't mess something up by foiling this out and bringing it over. It starts off not factorable. What the hell do I do? Right? If I could put it in this form, where I have something squared equals a number, I know exactly how to do it, right? So what I'm talking about is this. If I have a situation like, let's make it a little less even. Let's make this a 6. You'll see why here in a bit. Can you factor that? All right, good. If you can, you're better than me. So what the hell can we do? We can't. There's really, at this point, there's nothing we can do. If you know quadratic formula, it's great. It's too early. But you can't use it here. That's where we're headed. Oh, it's too bad. We officially don't know yet. So if I could just somehow do something to this so I can make it look like this. You with me? If I can make that look like this, then I could do that. Right? And it's a way around the fact that I don't know how to factor. So what we do is something, here's what we do. So we're going to do this problem here in a little bit. We've got to talk about how the hell to go from here to there.
So this one is subtract the 1 over.
Yes, that would be the first step. But let me get there. Oh, okay. Somebody's excited about it. I normally get the opposite reaction.
And then you usually just do it both sides when you do that.
So let me ask you guys a few questions. Here's a little background motivation, right? You're not going to be at a play. I need your motivation for a character. This is motivation for why this process works. What would you get if you did this? What would the answer be?
X minus.
So x squared,
Minus XX
6x.
plus 9.
All right, is everybody cool with that? Notice how how's the 6 related to that number? It's twice. Right? If that number's half, that's twice. Either way, I like it. How is that number related to this? It's squared. Cool. So if I knew, if I didn't know that, how could I capture what that is? If I didn't know what that number was, and I just had that, what would I do to this? Cut it in half. And if I didn't know that number, what would I do to this number? Square it. You guys got to wait. Let's do one more. If I had x plus 10 squared. And 10x, 10x, 20x. So again, this is that one twice, right? It's double. So half of this is this number. And this number is this number squared. So that's the pattern, right? That's what math loves. Math loves patterns. So what we're building towards is, if I had this. Yeah, this is. Okay. Fill in the blank. I hate filling in the blank, but it's good for explaining stuff. To get this number, you do two things. There's a two-step process. The first step is cut this guy in half. And actually, if I cut the guy in half, I get what that number is, don't I? Yeah. Remember I kept saying whatever that number is, half of that guy. So if I cut 6 in half, cut the middle coefficient in half. Square. You can spell, Jeff. No, you can't. So I get 6 over 2 is 3. That is kind of kick-ass cool. That actually tells you how it will factor. So I can go ahead and put that positive 3 right there. Second step tells me what I've got to put here to make that true. Because obviously right now that ain't true. So then I take the 3 I just figured out and I square it. And I as in me, not as in imaginary, don't forget. So that tells me what number I put there. So now that's true. So this is what's called completing the square. You can kind of see why. I figure out what number do I have to add here so that this resulting thing will factor like this, like a square. If I can do that, I can easily solve all these equations that are not factorable. How many things are not factorable? An infinite freaking number. Holy crap. Julian, you're going to ask him to move? Yeah. Good, thank you. I love it. All right. So, to solve this one, you guys had a good suggestion for the thing. Good suggestion for the first step is to move that one over. Make some space, right? Whatever I figure out has to be added here, I also have to add it to the other side. That's a big place where people make a mistake. Then you get these freaky ass answers. It shouldn't be as freaky. So we basically just did this one, but let's kind of put that here just to make it all official. The first step is cut the middle dude in half. And that's what's actually going to be how this thing factors, right? So down here I could put x positive 3. That's how this is going to factor on the next step. All right, so the first step in doing this, completing the square, actually gives me the answer on how to factor it. Now what number do I have to put here and there? Yeah, you take the number you just got and you square it. So then I can add 9 there, add 9 there. So the minute I add 9 there, this now does factor like that. So now I'm kind of continuing the problem here, right? So this middle step is just, what do I have to add there to make it possible to keep going? I factor it. What do I get on that side?
8.
And now you guys can finish that out, right?
Yeah.
Go ahead.
So whenever you add that last number,
You always add it to the.
Yeah, whatever you do to one side, you gotta do the other side. So I can't legally change the value of one side and not the other. Okay.
I thought that once you cut, like on the first step, you cut the 6 in half, which was the 3. I thought you put the 3 on the end.
With the 3 in how to factor, that goes in how to factor it, right? So to solve an equation, I'm going to take this and rewrite it factored here.
Oh, okay.
So I can do the first step and immediately put it there. And the second step goes on both sides to make that true. And then I can kind of keep going. Good, good, good. So as you guys are finishing it out, thankfully I actually have a handout that spells out those steps.
So since we don't have time, we'll take the test
So it's still
Next test is still Tuesday.
Tuesday.
Yeah. So I handed out that updated homework sheet.
So x equals -3 plus or minus 2 square root of 2.
Yeah, I like this one because you can simplify the radical. Sounds right. All right, so real quick, how'd you guys do here? What's the next step? Square root. Immediately put plus or minus. All right, that's the two possible roots. Something squared equals something. It's a positive root and a negative root. So we get both of those. X plus 3 equals plus or minus. What can I do with this? That you must do, or else you lose some points. 8 can be broken up as 4 times 2. Square root of 4 is 2. Square root of 2 is, I don't know. Let me stop right there. You guys remember that? You with me? So now that we know how to simplify radicals, it's just like reducing fractions. If you don't do it, it's bad. You've got to do it. Okay. And then the last step, subtract 3. And that's, you could stop there because you could break it up, but what good would that do? Are they like terms? No, there's no like terms there, so just stop right there. Okay. Yes, sir.
So anytime that we have a number from the other side, it's added to the squaring area, even though there's a 2 in front of it. If there's a plus or minus, we can't do anything.
No. It's the fact that this is 2 times this. So I have to multiply before I can add or subtract. Order operations. So I can't put the negative 3 and the 2 together.
Why not?
Because there isn't a 2 in there. I don't see any 2's in there. And it's not because I'm insane. It's not because I forgot my meds. It's because I don't see a 2. I see a negative 3. And I see a 2 rad 2. Are those like terms? No.
Those are tied together.
That's the coefficient of this, exactly. Tied by multiplication. The only way you can do anything to it is to divide or multiply. That's the only thing that would affect it. Cool? Alright. So that wasn't too bad. Let's look at one that's a little worse. How can I make this process, why was this process really nice? The very first thing we did, why is this really nice? Remember what I put in first?
5.
And what would have happened if I had a 5 there? Fraction. So I didn't want to bring fractions in too early. I wanted you guys to understand the process. Once you understand the process doesn't care that there's fractions in it. We care a little bit. Process doesn't care. All right. So let's look at one that's going to have some fractions in it. Oh yeah. Let's make this. Let's not make this too freaky here. Let's make it 20. That's it. So what's the, let me walk through this with you. Yeah, the first step, -7, cut it in half. Don't bring decimals in. Trust me. No reason to. The beautiful thing about this, you got to let go. The process tells you exactly what's got to go where. So you're kind of taken out of the equation a little bit. You just say, it says that's got to go there, that's got to go there also. There's not a lot of heavy thinking involved, which is nice. With fractions, you get a little freaky sometimes. So the first step, cut that guy in half. Second step, square it. -7 squared is 49. 2 squared is 4. So that's my little intermediate work, right?
So it's, I can just keep it.
Oh yeah, definitely. Please do. Right? Especially if it's a fraction that if you make it a decimal, it doesn't stop. If you stop it somewhere, you're wrong. So just keep it fractions. Yeah.
So then on the other side, it's equals 12 minus 49.
So let's do this. What do I have to put here?
Plus.
Negative
Plus.
This number goes there. So I got to do the same thing on the other side, right?
So it's always positive. Always.
Yeah.
Always.
Yeah. Because if you square something, and this is going to be real, right? Not all. I could put an imaginary number there, but we're not going to do it. It's going to be a real coefficient. This is a imaginary coefficient. But I'm going to square a real number. It's going to be positive. It's got to be. Right? And think about it. If I have x plus a number squared, x minus a number squared, the last number is going to be positive. 2 positives multiplied by a positive. 2 negatives multiplied by a positive. So that's got to be plus. Okay, good. So the nice thing is, if I gave you this problem and I said factor it just by itself, you might freak out a little bit, but I know exactly how this guy factors. How does that guy factor?
-7/2.
This guy tells me exactly what to put in there. 0 factoring thinking needed. First step will always tell you how this guy factors. Let's check it. If I FOIL this out, don't I get -7 halves x, -7 halves x? And 2 halves of 7 add together to make a whole 7. And of course, this thing times itself, we just did this. We know it's that. Right? So it checks. Now, what do you get on the other side? Good. 48 over 4 plus 49 over 4. 27 over 4. Yep. And now, see, now all that work was to get it to that form. So now you know exactly how to attack that form. So you're right, take a square root, plus or minus. So on this side I get x minus 7 halves. Over here, what's the square root of 97? I don't know. What's the square root of 4? 2. So you always do what you can, don't do what you can't.
Add 7 halves to
Yeah, and then add 7 over 2, you're done. So you get ugly little pieces in there. It looks not pretty, but there's not a lot of work you got to do with those pieces. Yeah.
Where did you get the 97 from?
Oh, how do you add these two things?
Oh, okay.
Yeah. Be real careful when you add a fraction over. You still got to get the LCD there. So the last step is to pull it over. And of course, you can put it all over 2 if you want to. Make it one big all over 2 thing. Yeah.
I just got confused by parentheses x minus 7.
Oh, here.
Yes.
That's what this factors to be. And thankfully, I don't have to worry about how to factor this because that number tells me exactly how it factors. When I cut the middle dude in half, that's exactly what's got to go here. Period.
What about the x? Where did you get this? Oh, you factored
So this, I'm taking this
Oh, okay, got it.
and I'm factoring it to be this. And I know it's going to factor to look like this because I completed the square. That process makes it factorable to something like this.
We'll go back to it.
Because you squared it.
Okay, so when you added the 49 over 4
Yep.
to the 12,
Yep.
that the one that you like filled in the blank, it disappears?
The whip, sorry?
Because
The
This here?
yeah, it disappears.
No. I factored this. So what times itself makes 49 fourths? 7 halves. So if I get this,
that becomes
on the next step, I want to factor this. Right? So if I had to factor this by hand, I'd say, okay, that could be 7/2, maybe, because that makes 49/4. X minus, and thankfully minus 7/2 is a full -7. But I don't have to do that work. To solve this, I'm trying to add something here so that this becomes factorable nicely to a square. That first step always tells me what goes here. That's beautiful. So I don't have to do this kind of work. Okay. Always. Completing the squares is stupid powerful. I don't care what you put here. It can move shit out of the way, put what needs to go there, and it'll factor it. It doesn't matter what's there. So, 2 other little situations to look at. And then I'll let you guys, some of you are probably doing the ones on there already, but, yeah.
Oh, no, sorry, I was stretching.
All right. So a real quick little one here. Let's see. Sure. Yeah. This is an easy one. I just put one little careful thing in there, right? So yeah, what do you have to add to both sides? So you take the middle, cut it in half, you get -1. Square -1, you get 1. So that's the thing I have to add here and here. So now how do you factor this? Yeah, x minus 1 squared. -11, and you're not allowed to stop and say no solution because we have 12/8 under our belt. We know complex numbers. We can take the square root of a negative number now. Right? So be careful. Huh?
No solution.
Okay. Okay. Let me pretend like the last 30 seconds didn't happen. So we have 12/8 under our belt, so we can handle complex numbers, so we can totally take a square root of a negative number. Right? Next step is square root, plus or minus. So I say plus or minus square root of 11. And you can put an I at the end, but do you see how it looks like it's inside the radical? So you always kind of put it out front. So I root 11. How did I get there real quick? I'm not sure. If I look at square root of -11, how can I break that up? You might think there's no way, but there is.
Square root of -1.
Good. Square root of -1 times square root of 11, right? Square root of -1 is I. Square root of 11, I don't know. Bam. So, real quick, little lightning round. Square root of 9 is, what's the square root of -9?
I.
3i. It's okay there. There's no square roots. You can put it afterwards. You with me? Square root of 16 is 4. Square root of -16 is 4i. You with me? Anytime I have a negative inside of a square root, it can effectively come out as an I. That's what the square root of -1 is.
So with the negative on the outside of it, if it was negative root -16 would be -4i.
Yeah, exactly. Because the root's -16 is 4i, and the negative is just out there. Good.
You have to get to fourth power and stuff, you can do that too.
Because I is.
Fourth root is more interesting.
Okay.
Yeah.
So we'll just say that.
Does that become actual?
Fourth root of -1, that could be like a bonus question. Because the fourth root of -1 is like the square root of the square root of -1. So it's like the square root of I. And we're not going to go there in this class, sorry. If you wanted to, we're not going to. If you add 1, you're done. So if you get negatives on the other side, you can't stop. You can't just say no solution. We know complex numbers now. You got to keep going.
We know that yesterday.
Huh?
Yesterday we know that.
Yeah, hopefully it carries over. One thing I've sort of driven right past is the fact that every time we've done a problem, I've had a 1 here. And this whole process is built on there being a 1 here. So if there is not a 1 there, what would I do?
You just divide that.
Divide by it. and you bring in fractions, but you really don't care because hopefully you realize you don't actually have to work with them very much. Right? So with that said, if you look at the bottom of the handout I gave you, there's two little problems down there I want you to do right now.